this a little bit before. We have what we're called rows and columns. A matrix is just a way of putting data in a rectangular form. When we did this before, we did it with systems of equations. We found that using a matrix was the very easy way to solve those 3x3 systems, because all you do is press a couple of buttons and it did it for you. Well, what we're going to do is kind of talk a little bit about how all of that works. It's just a matter of knowing how it goes. When we're talking about matrices, we say that, is this a 3x2 or is this a 2x3? Well, it all depends. Depends on how you're saying these things. Usually what happens is, remember rows, because you go row your boat, goes left and right. Because you can't row up and down. You'll be gently down the stream, but you.
Caleb's face on the boat?
I didn't think about that. That's a good idea. If we do this correctly.
You just gotta put it on the guy's head. There you go.
It's got like a fat head.
It actually looks like that.
All right, let's see. Oh, I have to reanimate it.
Oh no. Is this really working?
I think it's
Yeah,
I think
all
it is.
like, this is really gonna be ending.
It just makes everything funny. What'd you learn in school today? Caleb's face makes everything funny. Anyway, matrices, don't write any of this junk down. They call them row matrices, column matrices, square matrices, zero matrices, all that kind of junk. What happens here is that if it's a row, there's just one row. If it's a column, there's just one column. If we talk about them in terms of, if they say that it's 2x3, means there's 2 rows, 3 columns. It's always rows, then columns. Rows, then columns. So that one, the first one would be a 1x4. 1 row, 4 columns. The second one would be a 2x1. 2 rows, 1 column. The third one would be a 3x3. 3 rows, 3 columns. So that's called a square matrix. The last one, what would the dimensions of the last one be?
3 by 2.
3 by 2, 3 rows, 2 columns. So it's 3 by 2. And then it's just called a zero matrix because they're all zeros. The dimensions are important, more so when we talk a little bit about multiplying, because you have to have the same scenarios, and they don't have to be identical, but there are certain things that have to happen in order to be able to multiply 2 matrices together by hand. Like I said, it's just a matter of remembering that it goes rows by columns. But what you can do with these things is straight math. So if I'm looking at the first one, since those guys have the exact same dimensions, if you will, they are 3 by 1s, 3 rows, 1 column for each of them. Since their dimensions are the same, you can add and subtract them together. So this becomes 3 plus 1.
4.
Good job. There's a fly in here? This is really all this is. What's -4 plus 0?
-4.
What's 7 plus 3?
10.
Oh, that was a 4.
Wow, that was hard.
There you go. What's wrong, Jared? Is that too much math? Okay. Now the next one, all you have to do is match up the entries and perform the indicated operation, if you will. So they're both are those 2 matrices the same dimension?
Yeah.
They're both 2 by 2. They are a square matrix. 8 minus 2. 6. I know it's tough. It's Tuesday. 3 minus -7.
10.
4 minus 6.
-2.
0 minus -1.
1.
SMRT. And then, what do I do for the last one?
Oh, no.
Add another row, same thing.
Do they have the same dimensions?
No.
Can't do it.
Okay.
So it's like, beat it?
No.
No.
No, doesn't work.
No.
Can't do it. Because they have, in order to add or subtract it, they have to be the same size. They have to be the same dimension. If they're not, you can't do it.
Does that work with multiplication?
No. No. And when we get to multiplication, there's a rule.
Wait, if it was like 1 by 3, the other one was 3 by 1, could you do it?
No.
Okay.
That's where you're going at with multiplication. When that happens, you have, well, in multiplication, those two have to be the same to be able to multiply them together. So a 1 by 3 matrix, if you multiply it by a 3 by 1, so 1 by 3 is one row times a 3 by 1, which is 3 rows. You could do that because 1 by 3, 3 by 1, the 3's are the same. And we'll talk about that in about 10 minutes. Okay? Yeah, easy.
So, like, the numbers are grouped, right? So could you put like a whole 1 by 4 to the 12th power or something?
Yeah, like scalar stuff. Yeah, absolutely. If you had a matrix where it was just number, a lot of numbers,
Yeah.
and if it was squared, you square everything inside it.
Okay, so what if it was the 4th, and then you did minus number squared?
Well, what you're doing here is the square is going to everything on all the entries. It's not squaring the actual. You're not like making. You're trying to make this a whole lot
Yeah.
worse than it's supposed to be. It's not.
No, I get it. I just didn't know if this.
Yeah, no. Don't worry about that. Seriously, you don't. I don't think you'll ever even see anything that's square. To be honest with you.
Okay.
Okay. What you guys are going to do is stuff like this. It's scalar. Okay. One of the things that we're trying to do more of is what's called scalar addition, scalar multiplication. It's basically working within phase shifts of ordered pairs. You can write matrices as ordered pairs. So, and you're basically, what you're doing is tripling it in size, if you want to think of it that way. Your two ordered pairs. You're tripling a segment. The segment from 2, 0 to 4, -7, it's being multiplied by 3. It's becoming 3 times as large. Okay. That's kind of the idea with one of these things come into. What I'm going to show you guys in a little bit when we get into the determinants and stuff. There's a way to use matrices really easily to calculate areas of triangles. It's so easy. Okay. Now, this is basically like, as we were saying, it's a giant grouping symbol. What do I do with that 3 to all the entries on the inside of the matrix? That's all it is. And to be honest with you, the thing you guys are going to screw up is just forgetting your sign. Done. That's it. Order of operations still hold true when you go to the next one. You have to multiply that first matrix by -2 prior to adding it to the other one. And a lot of times you can probably do that in your head. Okay. There's not a lot of really hard math here to start with. So, what?
Just said to start.
Well, I'm not going to let you use a calculator, so sometimes that gets tough. For example, -2 times 1 plus -4, you get.
Wait, what?
Uh,
-2 times what?
2 plus -6.
I don't know what we're doing.
Oh, you're just going straight across.
Yeah.
-6.
6.
Yeah, 14.
6 and -4.
I think that's what you get.
Oh my God.
That was 666.
66.
The devil's in matrices as well.
So you guys -2
Okay.
plus. Oh, that makes sense.
Oh boy! Solving equations!
What I do?
Alright, here's what's happening. There is, because you're going to solve for x and y. Because what happens here is that you're taking all of this, and it just has to equal this. You know, it just has to. Now, what's going to happen here is that you have 4 entries in a 2x2 matrix. And obviously, there's 4 spots. What you're going to wind up doing is that you have what works out to be kind of like a 2 or 3 step equation to make it work. Here's what happens. If you go through the first part and see how it's written up for the first entry, that top left entry, what it says is 2 times the quantity 3x plus 4 has to equal 26. That's all that says. If you follow through where it's going. Okay? Oh. The second one, if I do 2 to the negative 1, it's 2 times negative 1 plus 1 has to equal what?
0.
So
0.
are you solving for x and y, or are you solving for the final?
We're solving, well, the final 4, this is going to be your answer.
Oh,
But you're going to figure out what x and y are.
so you really don't even have to pay attention to like the 8 plus
No.
negative 2?
No.
Okay.
No. And that's why I'm showing you that what's happening is it's 2 times the 8 plus negative 2 has to equal 12. Okay. And then you have 2 times 5 minus y has to equal 8. So what you're doing here is you're just setting it up to solve these quick 1-2 step equations.
But you really don't have to do 2 times 8 plus negative 2.
What's that?
Like the bottom left-hand one, you just wrote 2.
No, I'm just showing you how it works because this should equal 12. So I mean, 6 times 2 is 12. So yes, 12 equals 12. Okay. Here you wind up with 3x plus 4 has to equal 13.
So is it ever not going to be right, like where you would have to write out the bottom one and then you...
If it's not right, then you did something wrong.
Oh, okay.
Because what they're telling you here is that it's going to equal 12.
Okay.
Okay. That's all it's saying.
X is 3, y is 1.
So x is 3 and y is 1. That's all this is, guys. It's just a weird way to show how it works out to set up a 1-2 step equation. That's all. Miss Izzy,
So
very questionable this morning.
So if they weren't the same, like it wasn't 2 by 2, then you couldn't do it?
Correct. Yeah.
Okay.
Sir,
What do we need? Like, what are we gonna do with them?
remember how we did this a little while ago where we solved the 3x3 equations, the systems equations real fast? Oh, yeah. This is where the stuff comes from. And it's kind of like the hindsight idea of maybe we probably should have shown you a few of these things prior to telling you when you're going to use them, because it would be helpful to know what's going on. It's kind of like how we started the school year using those sequences and series, and all you guys had to remember how to use logarithms that you all knew so well. Remember that?
So what that is like a system of equation plus a system of equation times 2 equals.
Yeah.
Okay.
Yeah, a lot of this is systems. It's just another way of grouping through. Here, take a minute and solve it. And like Izzy was saying earlier, do you need to set up and write out all 4 of them? No. No, because negative 1 plus negative 7 has to equal,
Whatever you said it had to equal.
y. So what's negative 1 plus negative 7?
I don't know.
So what's y?
I'm still writing it down.
I'm sorry. Getting ahead of myself.
Obviously.
That never happens.
Never mind, no. When we have questions with X and Y,
What do you mean?
Like say it was 3x minus y.
Oh, no. You're really thinking words.
solve by like 8 plus a negative 8 x negative. Wait, what? Did I just mess that up? Oh, I'm looking at the wrong one.
Don't do that. So 3x minus 4 has to equal negative 16. Is x equal to? like I said, when you get to a system, or I won't say system, but when you get to a matrix like that, you do not need to write the whole thing out, guys. You're just pulling out the information. Multiply. Like I said, I'm gonna do a little bit of both. I don't think I want to get too crazy on the multiplying today. I might, I don't know. It depends on how much. Now, like we were talking about earlier, when you're adding and subtracting, you have to have the same dimensions. When it comes down to multiplying, what happens is you have to have the following thing to happen. You've got rows by columns. All right, row by column times yes, ma'am.
How sure are you on your grammar? Is matrices, like, is that correct? Are you positive?
That is correct.
Okay.
Yeah, that is the plural of matrix.
It's that and it's
Yeah.
wrong, that's how I'm gonna spell it for the rest of my life.
No, it's
all your
right.
fault.
No, I swear to you, it's right. You can look it up in your book. I'm not lying. I spelled this one correctly.
Okay.
What happens here, in order to multiply matrices together, these two have to be the same. The number of columns in the first has to equal the number of rows in the second. If that's not the same, it won't work. Okay.
So row times column times row times.
Matrix, this is the matrix here, you know, this matrix times this matrix.
Wait, so
These are rows by column.
do the outside numbers have to be the same or no?
No. The interior numbers have to be the same. Like Jared was saying earlier, a 1 by 3 and a 3 by 1. So it would be a 1 by 3 matrix times a 3 by 1 matrix. That would work because these two are the same numbers. Okay.
So you could do 1 by 3 times a 1 by 3.
Correct.
Could.
No.
So, but you could do like a 1 by 3 times like a 3 by 4.
Yes.
Okay.
And the result matrix, when you multiply these two together, it would equal the outer numbers. The result matrix would be the outer numbers for what it is.
So 1 by 1?
Yeah, it'd just be one entry. And I'll show you how that works. It's kind of weird. It's kind of weird when we start talking about 1 bys. I'm going to start with just regular 2 by 2s, a square matrix, and then we'll get into some of the funkier sizes later. Okay?
So the two outer ones is
Will be
going
the-
to be
yes.
what it's equal to?
Yep.
When you say by what is equal to, you mean like that's what the dimensions are?
Yes, that would be the dimensions of the new matrix. So the one that Jared was talking about earlier, the 1 by 3 times a 3 by 1, it would result in a 1 by 1 matrix, which is a single entry.
Yeah.
It's kind of weird, but it's how it works. Okay.
Oh.
So the interior numbers are the same. The outerior, the exterior numbers will be the result dimensions of the new one. Okay? That's how that works. Let me show you how you do this with a real basic 2 by 2.
So you can do 2 by 2.
Yep, 2 by 2 times a 2 by 2 would result in a 2 by 2. All right. I know, and I know that this is a 2 by 2 matrix, and this is a 2 by 2. These two numbers are the same, so it's happy, you can do it. The result matrix, when I multiply it out, is going to be what? It's going to equal a 2 by 2 matrix. Now I have a really nice shortcut for multiplying matrices. It works. Don't ever read what your book does. Don't follow through what they try to show you on all the little tutorials and things like that. Because they say multiply rows times columns, rows and all this, and you add all this stuff together. You get lost really, really fast. I got so frustrated in my first class was it? It was like a linear algebra class at Northern when I was in college. It was like 240. So it was a 200 level class, maybe. Yeah. And I got so mad that I kept screwing up matrices over and over and over again because I kept trying to do it the literal way, trying to follow full definition. And then my wife, my girlfriend at the time, she said, "Here, try it like this," and she showed me this trick, and it works. One of the other things they use matrices a lot for are vectors. Not bearings, but they use it for vectors. It's a lot of weird math can be based off of this. And it's a really nice, easy way to multiply matrices. If you find out the dimensions of what your new matrix is going to be, you know that you're going to have 2 rows, 2 columns. So what I'm going to do is I'm going to write this down, this first matrix, I'm going to write it down twice. And when we get to different dimensions, you'll see how many times you write it out. Here's what I want you to do. I'm going to take this, just put it here. I'm going to take this matrix, I'm going to write that down twice. And now you do the following pattern. You always start in the upper left corner of the matrix that you have, and you start writing these numbers down. 1, go below it. 2, go to the next one. -4, and 1. All I'm doing is starting at the top. I go 1, 2, -4, 1. I'm just putting them in order like that. Top down. Yes, sir?
Is there a reason why you have it spaced out so much?
Yes. Those numbers that I just put in those columns, those numbers repeat below it. So you only have to write it out really once, and then you just follow what you just did above. And now what goes between them is this. Because you'll notice now you have 4 entries. You created a 2 by 2. What you're doing is you write down number of time, excuse me, or bless you, excuse you, whatever. I say excuse me when my kids burp and they don't say excuse me. So I apologize. I was with my children a lot this week and they burped a lot. Because, you know, burps and farts are funny. They are.
Can you divide matrices?
No. You have to do scalar stuff. So here's where we go. What's 3 times 1?
I don't know.
3.
Plus 4.
7.
7.
So your result is going to be 7. -1 times 1.
1.
Plus 0.
Next one.
0. Oh, I'm.
And the top right, we got 3 times -4 plus 2.
10.
And 4. There's your answer.
How do you combine the two?
What do you mean?
How did you combine those 2 sets of 4 into 1?
This equaled the top number.
Okay, gotcha.
These 2 equaled the next one, and so on and so forth.
Okay.
Does that make sense?
Yeah.
So you go all the way, for when you're filling the numbers, you go all the way down, and then you go to the next column, go all the way down to the next column.
Yep. That's all it is. That's really all this is. All right. Let me show you another one. And what you wind up doing, well, I'll show you this in a second. This is another 2 by 2. Are we okay with that?
Yeah.
Okay. Since we know the answer is going to be 2 by 2. You okay with that? How many columns are in a 2 by 2?
2.
2. That means we have to write down the first matrix twice. It's kind of another way to remember it. If it's going to be a 3 by 3 times a 3 by 2, yes, ma'am.
Did you write this?
Yeah, but you always work from left to right. Oh, yeah. Sorry. Yeah, you could, but you want to remember that when you're doing matrices, you can only multiply going from left to right. You're multiplying the first one into the second. It doesn't work the same pattern going the other direction. Yeah, it doesn't always work. So you always say matrix A times matrix B won't be the same as matrix B times matrix A. It's weird how it works. Because you start messing with the way that the patterns work, it doesn't match out the same numbers. So I'm going to write down that first one. And this is the reason why I spaced it out so much, because I was going to get those additions thrown in. So I have 1, 3, -4, -2, 1, 3, -4, -2. I just start again at top right, or top left, excuse me. 4, 0, -1, and 3. Put plus signs between them. And I just follow below it. It's a nice, clean pattern just to follow. And it's always nice when there's a 0 involved. It's a lot less math. So when we do this, we're going to get 4 and 12. I know that. -13 and -9. And like I said, to be perfectly honest with you guys, you'll forget when you're adding or subtracting with a negative. That's really the only thing you're going to screw up.
Do we divide them?
No, you don't.
Did you say graphing? You said like the calculator with graphing.
No. The calculator won't graph these. They solve all of these.
Oh, okay.
You press a button and it does it all for you.
Are we gonna have to get these?
No. No, we're not graphing matrices. What matrices would allow you to be able to do is you could use. I might show you guys how to graph 3 dimensions.
No.
It's kind of cool.
No.
We might have time.
Shoot me down.
This is not a democracy.
All right, I'll just use one.
Okay. Let's do this one.
Just flip the page.
I know.
Okay.
Yeah.
Not possible.
It's a 3 by 2
And 2 by 2.
and a 2 by 2. So it's hold my bluff.
Oh, shoot.
Can I multiply these together?
Yeah.
Yeah.
Did you write that 3 times?
Wait, what's the other say?
No, how many columns am I going to wind up with?
6.
No, hold on. I'm going to wind up with 2 columns. So we know that this is going to work because these two numbers are the same. And I know then my answer is going to equal a 3 by 2
Why do you know that?
because these are the outer numbers.
Oh.
Okay? I know the answer is going to be a 3 by 2. So since I know it's going to be a 3 by 2, that means it's going to have 2 columns. So you write out the first matrix twice. So you write out the first matrix twice. 3, 3, 0. 3, -2, -1. -3, 3, 0. 3, -2, -1. Yeah, I think it was, wasn't it? Yes, it was negative. Okay. That's going to help create my 2 columns. And now I do the same thing with that second matrix. I just start at the top left and I put it in here. 1. Go to the one below it. -2. 0. -1. And what am I going to do between these 2 values? And I put another one here. And what do I do in the subsequent values below?
Same thing.
Same thing. Do you guys pick up on the pattern, how this stuff rolls through? It's not very difficult. It's just pick the pattern and just follow it.
For some reason, I'm confused about how you fill out, like, I know how you get the first set of numbers. How do you get the ones in front?
What I'm doing here, Ben, is I'm starting with the top left, and I put him here. Then I go to the next one, I put it here. Oops.
Okay.
What's that?
Yeah.
Here.
I put her, then I put it here, then I put other it there. All I'm doing is starting at the top, work my way down, and then just go across the top. Okay. And then each term below that is the same value.
Okay.
Yeah, why would you want to say that?
What's that?
-6 plus -3.
And you guys see how it's very easy that you can screw up a negative sign when you get all these numbers thrown into one?
Then can we put a dummy calculator into this?
This I probably would let you use a dummy calculator, but you should need a calculator for 3 times 1.
-3.
Well, I wasn't looking at that one, I was looking at this one.
Yeah.
So -3 plus -6 is
-9.
-9. 3 plus 4 is 7. 0 plus 2, 0, -3, 0, 2, 0, 1.
Got it. Good.
Yay.
Woohoo, I got it right.
Okay, wait, how did you know, like, how did you do the big box?
The big box, remember, when I know you're okay with it, you knew that your answer is going to be 3 by 2, correct?
Yeah.
Okay. If you know your answer is going to be 3 by 2, you always write out the first matrix that many times. The number of columns for the result.
Okay.
Always. It'll always work like this.
Okay.
All right.
4 times.
What's that? 4 by 9 and 9 by 4? How many times do you have to write it out? 4 times.
What?
That's all.
I don't get it.
So if it was a 3 by 3
So if it's 13 by 2 and a 2 by 7, could you multiply those two together?
Yeah.
Yeah. Your answer, these two are the same, so your answer would be 13 by 7. So how many times do you have to write out the first matrix? 7 times.
What's the highest think you'll get to?
Oh, I got something for you later.
100? Oh, that's the price thing you're talking about.
I usually give you guys a determinant of like a 9 by 7, which is awful, and you make you crank it by hand and show all your work. It usually takes a couple of pages.
Wait, how much extra credit are we taking?
I don't know. Don't worry about it.
None. You get none. The joke's
But
on
if you
us.
could take
3 by 3 times a 3 by 3 will give you a. How many times do you write out the first matrix?
3.
Okay,
Trace.
go for it. Yeah, do it.
What's the guy doing?
So I wrote it out 3
I
times.
don't care.
So I start at the top. It's times 5 plus times 3 plus times -4 times -7 times 12 plus times -5, and then you have 4, 6, -12. And then these 3, 4s, and 5s, those duplicate going below. So if you did all of your math correctly, you get yes, I just put it in the calculator because I.
Gosh, I was so close.
You should get that if you did math right, or unless I pressed the wrong button.
Oh, you know what? I was more alive than the rest is right.
You.
Let me see if I got it.
Yes, because I pressed all the right buttons.
Oh, it's 55?
That's what it should equal. And this is what, I also was just saying, this is what, it's not tough. It's just you're gonna make a stupid mistake with a sign when you're adding like 3 plus 4, you're gonna tell me is 12.
So 14 plus 60 is 74.
Can we do like 2
Minus
plus?
15, that's 59.
Let's do
It's
this.
not 55. You gotta get me.
Yeah, it is 59.
Do we,
Yeah, you got it
do we
wrong.
not?
I didn't get it wrong.
Yeah, you did.
No, I didn't.
14 plus 60 is 74, minus 15. Whoops, put it there. Oh, dang it. Oh, dang it. No, I just pressed wrong. It's 59.
3 through 36? Oh, okay.
Sorry, I didn't realize I wrote that.
Maybe never say that. He wrote it down.
He did write it down.
Saturday, I think I said, yeah.
No, that's.
Okay, sorry. Get my mom the river, I went to the shore.
Just so you know, what they're doing here on that second part of 4.2 is they're giving you 4 different matrices, and it'll say like 2AB. It'll say this, 2AB, which means it's 2 times matrix A, and then you have to multiply it by matrix B. So you have to distribute the 2 into all that first, and then you multiply the 2 matrices together. Yes, sir?
Is this on your website?
Yeah, I put it up there. I put it up, I put another tab in there, I'll show you guys, thanks for reminding me, just so you guys see it.
27 through 32?
Yeah. I put a chapter 4 tab here, so it's right there. Oh, I gotta change all those. That's not the homework for you, this is from a year ago.
I'm really glad I did this.